Hi everyone, my name is Cheryl Wiygul and today we are going to talk about light frame construction. Light frame construction, which is also known as framing, is the building technique of creating a structure out of dimensional lumber like 2x4s, 2x6s, and engineered wood like plywood, OSB board that is regularly spaced and fastened together to create floor, wall, stair, and roof assemblies. Wood light frame construction is the most versatile of all building materials. It is, light frame construction is wood, but it's not heavy timber. Platform framing is the standard that best meets current building code requirements for residential homes and commercial buildings 3 stories and under. The process of platform framing builds up in a platform, like stories in a platform, and up from a solid foundation. There's many important components or steps to light frame construction. It requires a solid concrete or wood joist foundation, erecting the wood frame, floor joists and floor trusses, roof trusses and rafters, sheathing of the subfloor and the exterior, fastening and attachments to ensure a continuous load path. The majority of light frame construction is built on shallow foundations such as concrete footing, basements, or slab on grade. And we don't have basements in Northwest Florida because of the water table. And actually where we are, we do build, some with concrete piers and things with more structure because of the hurricanes. So throughout this presentation, we're going to look at pictures of just a small light frame construction project. So this is the prep work for the slab for that. Is a monolithic slab. So they trench out the kind of like a footer for it. Even though it is a slab on grade, it's like a slab on grade with a footer. And it has the vapor barrier there and everything. And then it's right before you pour the concrete. It's all one pour. Then after the foundation, you're going to review your framing plan for your structural member sizes, spacing, layout, and other specifics. The construction drawing should be regulated by the building code. So on the left is just a section of the framing plan for this little carriage house we're looking at. And on the right is a section from the building code showing you, where different anchors go and studs and sizing and things like that. So this is just a kind of a generic diagram of all the structural members of framing members for light wood construction. And you have to be really careful with construction terminology because a lot of these things have 3 or 4 different names because people just prefer to call them different things. So sometimes when you're talking, you're going to be talking about the same thing and you think you're talking about something different. One of the most important aspects of framing is ensuring a continuous load path throughout the structure by connecting and fastening the framing members from top to bottom in order to properly transfer the load to the ground and prevent uplift. And that's kind of a demonstration of that. It shows you from the slab up through 2 stories and then the top of the roof up there and how it's all connected by different kinds of fasteners. So after you do your first floor, you're going to want to attach the frame to the foundation with the 16-inch on-center stud walls in place and an additional reinforcement for the openings. The pressure-treated bottom plate, or the sill plate, this is an example of that, 2 different words, is attached to the foundation with the 1/2-inch anchor bolts. And actually, I think the book said 1/2-inch anchor bolts, and I think those were actually not 1/2-inch. I think they were 5/8 maybe. anchor bolts nonetheless, and metal straps. These are prescriptive measures that can vary depending on your geographic region. Like in this particular case, we're a mile from the coastline in a hurricane zone, so it requires additional fastening. Studs are vertical wood members spaced evenly apart and attached to both the bottom and the top plate of the floor frames. The walls of the story beneath each new level bear the load from above. The upper top plate overlaps the lower top plate and the corners to join the walls. The top plate is reinforced with steel strapping as well. I think these are 2x6s that are 16-inch on center, and because it's two-story, if it was only one story, you could do 2x4s, or if it was only one story, you could do 2x6s at 24 inches on center. Now we're going to talk about the floor joists, like moving up into, we're going to build a second floor. Platform framing starts with a floor frame attached to a foundation, and walls are raised and fastened to the floor frame. A floor is constructed of wood joists and subflooring. So both of these pictures show it's actually box trusses, so it's a little more than just floor joists. And the box trusses are toenailed and reinforced with steel strapping ties, and the OSB subfloor is installed and it runs perpendicular to the framing, and that's for structural reasons. Sheathing is an engineered wood product made from plywood or oriented strand board. That's the OSB. That's fastened to the wall. The wall and oh my goodness. Sheathing is fastened to the floor, wall, and roof assemblies. Roof sheathing is structural, providing the lateral bracing of the roof framing members, and it carries both the live and the dead loads from above to the rafters and the trusses below. So these are pictures of all thread rods, and it's actually the washer on top of the all thread rod, and those arrows are pointing to where they go. They can resist more force than the strap downs, and this actually is part of that continuous load path, and it does connects. There's like a J bolt that goes into the foundation, and then it comes all the way up, and then it's got the washer on the top there, on top of the top plate. And so that is a really important part of the continuous load path. Now we're going with the trusses. These are the roof trusses. The need for engineered trusses depends on the size of the roof span. I believe that it's 60 feet. I think if it's under 60 feet, you don't have to have engineered trusses. Of course, engineered trusses are probably better. On the right, you can see where engineered trusses have to be lifted with like a crane and put down, and they can't be left on the ground or anything like that because it could compromise them and get them bowing, and you don't want that. So they wouldn't fit right. On the left is like a stick framed hip roof, because this wasn't that big, and right now it's real hard to get trusses or much of anything. So this is an example, a really good example of engineered trusses. This is actually at Royal Pacific Resort at Universal Orlando. Just thought that was a good, like, perfectly symmetrical example. So for the roofs and like frame construction, hip roofs are probably the most common. Framers use a framing square to mark their rafter cuts. They don't have to do a lot of calculations, and then it's still accurate. And the rafters rest on the top story wall, and they're connected to the joist to transfer the load. And you can see them on the painted part on the left, where they're a little bit exposed out there. Now, if for some reason you wanted, a lot of times you'll have your rafters exposed, you know, for architectural, like design inside your house. And in that case, you probably wouldn't want all these metal straps and everything, but you can't not have them. So if you're wanting that for the aesthetic purposes, then you would have to go and use heavy timber instead of the nominal wood. So now that we've seen our roofs, we've gone over all the different components of light frame construction. So to summarize what we talked about, light frame construction refers to the utilization of dimensional lumber and engineered wood as an economical and adaptable building technique for small construction projects. Shallow foundations are used for light wood construction. Plywood or OSB sheathes the subfloor and is fundamental to the structural makeup of the exterior walls and roof. Proper stud, joist, and truss spacing, along with required assembly connections to create a continuous load path between building members, is imperative to ensure its structural integrity, and that all those additional attachments and that continuous load path is what really gives it its structure, because otherwise it could probably get blown over pretty easily. All right, I hope you guys enjoy learning about light frame construction, and y'all have a great day.